Now I'm talking about the sustainable textile AI in sustainable textile processing and natural dyeing. We know that the textile industry, I think most of us know the textile industry is the one and which has actually, I know, contributing to the pollution. Lot of pollution happens with these things because the effluents that are coming from the textile industries, they run into the rivers. And the rivers, when they run into from one place to another place, they also take the chemicals, the toxins that are all other things that are present, even the color. You can see that the photographs are being put up over here. So actually, they say that this is the most polluting. Maybe before that, maybe you find around pharmas and other things which are contributing to the pollution because most of them do not bother about treating their effluents that are coming from the mills. So that is they are called ETPs, and now Pollution Control Board is taking care that all of these people take up this ETPs, that is effluent treatment plants, and then only they can release the water into the water systems or water bodies. So it is called the elephant in the room, as a popularly it is called the elephant in the room, saying that this is contributing a lot to the pollution, and unless we control this, and the pollution will keep on increasing, and you find that there is an oxygen levels are low in all the rivers and all because of all these things, because maybe the chemicals that are present and maybe the carbon dioxide emissions that are being coming out from this. And definitely this is the fifth largest contributor of carbon dioxide emissions in the world. And that's why you find some of these countries, like developed countries like US and all, and they have stopped producing these things, and then they have sent these things to our I think Asian countries, where we are given a lot of uh, orders in order to transform the fabric into a usable one. So they all the processing is done in some of the Asian countries, but now they have realized that they have to have the manufacturing over there only in their country, otherwise there will be problem, they have to face the problems. The current situation is happening like that, and thus they have realized that they should not give this much of work to others, and they have to be self-reliant for this particular thing. And actually, among the other activities, textile processing means it starts from the fiber. The fiber is there, it is converted into the yarn, and the yarn is converted into the fabric. And the fabric, maybe it is woven fabric or the knitted fabric. And then finally, and it is either dyed or, given some kind of finishes to that, and dyed and printed. And then again, it will be finished and then comes out into the market, and as consumers we are taking that particular material. So what happens is that in the beginning there may not be that much of pollution that is occurring, maybe air pollutions and other things are there, but in case of this wet processing, especially for finishing, and also these two, that is dyeing and printing, they will cause some problems. And that's why effluents, or they are using a lot of synthetic dyes. That synthetic dyes are not eco-friendly, and they will not biodegrade, and so the color will remain, because in any dyeing bath you find that only part of the dye will be taken up by the fabric, and the other rest of the amount will be just left out in the this one. That is, we call it exhaustion of the dye bath will not happen continue 100%, but part of the dye will be left out in that. And then along with the dye, and there are chemicals that are being used. So that's why synthetic chemicals, synthetic dyes are always associated with the chemicals which are very, very harmful, like hydrosulfides and other things. And so these, most of them are alkalis also, and so all these things should be removed they are anticipating to release this water into the water bodies. So this is all these dyes, salts, and heavy metals, especially, and water bodies. These are all threatening the ecological balance, and thus they have to be removed. And that's why AA will be definitely helping in this particular things. Why we need the sustainable, say, this manufacturing or processing. So this is that everybody is concerned about the environment, and all of us, even we are educated or uneducated, and people know that the environment should be clean. When we want to give to the future generations, it should be clean. We should have a clean air, clean water, and clean environment to the future generations. And that's why we are going into the sustainable practices. That means sustainable practices means that is we should be able to give this kind of clean environment to the rest of the and in the future also. That means that we have to reduce the consumption of the water and also the energy. And if you are using water and energy, again this is a problem into the environment. And so we need to reduce this water and energy, and also chemical usage. You should not have many chemicals. So what happens is that in synthetic dyeing also, say for example, if you are using say bad dyes and something like that, and which requires say an alkali like sodium hydroxide, and also you use sodium hydrosulfide. And when you are using these two, and then we are not bothered whether this is actually enough or more. Even more, if people think that if it is more, and it will be able to give very good color. It's not that actually. And that's why chemicals usage will be more in that. And people who are employed for doing this are not that educated. And so in some of the mills you find today that they do not bother about taking the really educated people over there, or really technological people, technology people. But they try to give them some kind of, they take some people and who are educated or uneducated, and give them some kind of experience. After one year of experience with the same in the same machine or the same process, and they will be able to do it. And in that case, they will not understand whether they are using more of this particular thing. Then definitely they don't take less, because the color may not come. But if it is they will take more color and more of all these things, chemicals also, so that they are sure that the color comes out on the fabric. This is something where AI definitely will integrate. And and also to adopt eco-friendly processing methods, like you have an indigo and you have bad dyes, and all these things can be, you require sodium hydrosulfate in order to reduce them. That is, you have to remove the oxygen over there, and it's in reduced conditions. It has to be applied on the material. In that case, and we have to have something where some biologically made, a reducing agent, and that is what we require over here. And in case of natural dyes, we have something. No, we have some seeds which will give you that kind of thing. So, and we require that kind of eco-friendly chemicals, or not, I don't say chemical here, eco-friendly materials, in order to uh, get that particular effect that is being produced by the toxic chemicals like hydrosulfide. So this that's why we need these all these sustainable practices over here. And then these approaches will help protecting the ecosystems, and also the conserve the resources. That is what is required. And if you conserve the resource, and if you make less of these use of these resources, it will also it will also bring down the cost of the productions and other things, and also ensure long-term industry viability. So, and I tell you, because I'm having a lot of experience in the natural dyes. Natural dyes are supposed to be the alternative for these things. These things are derived from the plants and other natural sources. And these, that all of you know that they are biodegradable, because they are taken from the plants. And so the leaves and other things, they are going to biodegrade. And also they are environmentally safe, and they may not pose any challenges to the, and also, but they have the limitations that we have to speak about it. And to talk about the textile industry, that is the background, what is the background of this industry, and also that what is happening today. And the global textile industry is valued at about 1.84 trillion in 2023. And now it is increasing, and they are expecting to increase by 3.77 trillion by 2033. So because there is a demand, and also the demand is for the high quality and customized products, because people do not like to buy things which are taken by the which are owned by the other people. But these, customized products are being coming and coutures and which are made for the purpose of the a person, for a particular person or being asked for. And so the with the high quality and high customized products and also even textile, technical textiles and all these things, because of all these things, you will be able to improve the the demand for these materials, and the outlay will be 3.77 by 2033. If everything is happening okay, or if there are no wars or anything, and they will be able to definitely achieve this kind of outlays. It is our, if you come to the Indian textile industry, and it is in 2023, it is worth as 226 billion US dollars. And now it is projecting it to grow to 475.7 billion by 2033. And textile industry is contributing around 2.3% to India's GDP, and also 13% of to production, and employing around 45 million people directly. And and there is something that is coming up, because people are thinking that if AI is integrated into the system, and some of these people will lose the jobs. I'm sure that that will happen. But only thing is that, we have so many people, and why not use this human, resource for something else? Because there are many things that can come up, and many things that can happen, and so these people can be utilized for some of the other things. But here, because we cannot expect 100% quality, or at least 95, 96% of quality, by only taking the human knowledge into consideration, human skill into consideration. We need to have some the artificial intelligence integrated, so that we will be able to actually come up with a good quality. And because our eye, the human eye, cannot always detect things in what are happening in the fabrics, and so we need to have it integrated with the AI. So, and also in Indian market, and I'm happy to tell you that we have a strong domestic consumption, around 142 billion US dollars in India. And because we have, the people have increased their, the living status of living, and thus, they find that they have money in order to buy some of these materials, and that's why India is, especially Hyderabad, and also Delhi and other cities, the consumption is high, very high. And also they go for the fabrics which are customized, and also which will contribute to ecological balance. And also we are able to export significantly in few years, from all these years, like 37 to 38 billion US dollars to other countries. And there is one section of the uh, textiles now, that is Indian technical textile market. This is there, and technical textiles. I would like to talk about this one, because here we find that the technical textiles are being made by the countries like US, and also they come out with the protective clothing and technical clothing and all these things, by taking the fabrics from us, by taking the resources from India and other Asian countries. We have a lot of resources over here. These are being taken by them, and then so we are making the yarns. Okay, we can make the yarn whatever they want, and then we are exporting to them, and these things they are making into garments, and which are protect, and that, I think, technical textiles. The students who are there here, I think they will understand that there are Meditech and the Pack Tech, and say all these kinds of textiles, geotech and agri-tech and geotech and all. And these materials, we are able to now take up this one because of the AI. Otherwise, it's difficult to do it without the, say, the integration of the AI over here. And because these textile fabrics should be very, very qualitative, and they should be performing well, and also they should be able to meet the demand of the particular sector of the say garment making. And So it is expanded to increase by 23.3 billion by 2027. And because people are aware of goods and higher disposable incomes over here. So to cope up with this rising demand, so we can say that artificial intelligence can step in to boost productivity and also the drive growth and spark innovation across the industry. So we are talking artificial intelligence. I think Madam also, I think Mr. Mrs. Uh, I mean, Rita also talked about this one. And so, what is artificial intelligence? As humans, actually, we see something and we try to learn. We learn it, and then we try to understand it, and then we have that intelligence. The intelligence we have to in order to see it, learn it, and also understand it, and then we can reason out, and then with the reasoning, and if there is any problem that comes out, we will be able to solve that problem, and then finally we can make a decision. But here, the machines have taken up our task of that. I mean, taking doing taking the decisions in some of the in machining or anywhere. They are able to take up the decisions because uh, you know as a human, we will not be able to be available all the time. And also, we may be, and there are a lot of differences between one person to another person. That's how we know the seniors differ from the juniors, and the seniors will be there, and from them, the middle people will be learning, and then those things will be forwarded to the younger generations. And there is a lot of gaps that may happen in between. And that's why AI can be the artificial intelligence have come up, it is the ability of the machines or the computers to perform tasks that normally require human intelligence, such as learning, reasoning, problem solving, and decision making. So we have data like machine learning is there, and then data driven decision making is there, and then predictive modeling. So these are the things they see anywhere. For example, if this takes, we have to actually make the system, the machine, to learn about what exactly is what we are talking about. So a lot of data is required for this machine so that it will be learning it, and then it will be able to analyze it, and then comes out with the reasoning, comes out with the problem solving. If any problem comes in between, and why it is happening, and so what are the things, what are the mitigation things that we can take it up, and then we can finally it gives the decision. And sometimes we are not bothered about the machinery, and so we think that the machine's okay. The I mean After it gets if it is down, then we will take it up and all. And but this will give AI will give you warning that this particular machine and this particular belt, or maybe nut, or maybe something, that the spinning say ring frame or something like that, there are problems, they are coming down, and so please see that you have to repair this particular thing, so that there will not be any downtime when the machine breaks up. And so all these things happen with this particular thing. And so here, just I given one small this thing, that it is a simple a worksheet, like we have inputs like fiber, dye, and mordant, because the fiber is important for all these processing. Fiber is important, the dye is important, or the chemical that is used for the finishing is important, and the mordants if we use, they are all important, and also the dyeing conditions. So we have to first of all give the input data to the machine learning, and then the data analysis will happen, and then it learns, and then finally it predicts. So it predicts, if you take the fiber and if you take the dye, and if these are the conditions, and what kind of shade that we are getting, the color, and what kind of fastness that it may happen, and what is the process that happens over here. And so finally we get the efficient dyeing process. So this is what is artificial intelligence. And then so, first of all, we get into the spinning. In this, the fiber and the ion processing. These are the things that happen over here. And whenever there is a fiber that comes to the mill, generally ion spinning mills are different from the other mills, that is where fabric is made and also the processed. Sometimes you have three different things, or sometimes they are complex And I mean, all these things will be composite mills are there, and where the yarn processing is done and fabric is being made, and they are also dyed and printed and finished and then come out. So composite mills are not many, but you have generally the fiber and the yarn processing takes place. And here, the AI systems analyze fiber properties. You have a fiber, and the fiber is taken up, and this fiber has length. Some of the fiber important properties of the fiber are, we have the length of the fiber is important, and the fineness of the fiber is important, and the strength of the fiber also is important. These three we need not actually put this through a tester, and if it is a enabling spinning unit, then you find that these three are being read for anywhere. You keep it on the say take out the fiber from the bales, and if it is placed over there, and it easily reads what is the length, what is the strength, and what is the fineness of that particular thing. So by using this is a computer vision, and also there are sensors to optimize this blending and spinning parameters. So with all these things, this is it predicts yarn quality and also breakage risks. And that happens, what happens is there are number of breakage risks that are there in the yarn processing. And so unless you adjust the spinning parameters for the particular time and for with the particular fiber that you are doing with it. So that's called real time. And whenever you feel that the particular quality of the cotton that we have brought in into the I mean say factory, so this may have this many the breakage risk is there, and so this will be the yarn quality. And because it all depends upon the order that they get, a customer will require a particular quality, and so depending upon that they also take the fiber, they get the fiber, and they start the real time from there, and then start predicting the yarn quality and the breakage risk, and accordingly they will make the arrangements. You can ask me why not they go for the quality, but sometimes quality requires more of investment, more of the resources. But what happens is that the customer may not pay them that much. He doesn't require that much quality. Okay, and say for example you are using a towel material, and you are using a say your kurta material. Kurta material requires more yarn quality, and rather than the say the towel. So like that, and depending upon the end use of the product, also the quality is required. And so the breakages risk is there. Then in that case, the speed and other parameters of the spinning frame, and also the whole spinning system will be rearranged, and that is being done without telling, and say without the supervisor or whoever may be, without his knowledge also, it will make its own arrangements with if it is AI enabled. And so we can reduce. See, there are so many risks, the breakage risks are there. It breaks and one then, and then we have to remove that part of it, and then we have to again connect it with the other one, and also so it reduces increases the wastage and also the time of production. And so if it is AI enabled, then it reduces waste and also improves the uniformity. You can find here some of the things that are there. And so we are putting up together all these things, integrating over here. You can see that AI vision system analyzes the fiber properties. I told you that it will tell you what is the length, what is the strength, and what is the fineness of the fiber that we are taking. See, for example, if you want to take the fiber, and you cannot generally blend, fibers with a lot of difference in their fineness. Some of very coarse, and some of them are shorter, longer, and all these things are there. So when they combine together, they have some leverage between this, maybe a length of say 2.5 centimeters, and maybe they have a leverage of 2 to 2.5 centimeters, not more than that. In that case, the yarn quality will be affected. So a vision system, it's a vision system that is being used over here, and then it analyzes fiber properties, and then so the blend quality, how much is it is it's going to predict, how much quality optimal blend, how much to blend. You have so many bales that come out, and how much of each should be taken, how much of each should be blended together. So optimum blend and quality, for quality and strength. So these are the parameters that are being given by the AI without even looking at the machine and this thing. And then we have the sensors, and also these sensors will be monitoring spinning parameters in real time. So real time is a term that is being used here in the textile. This thing that is uh, so whenever an order comes, and it starts at that particular point. When the fiber comes, it starts at that particular point by involving the vision system, and then bringing the parameters, everything together till it is over. And so this is monitoring spinning by it monitors spinning parameters in real time, and also it will predict. That means this quality we are going to get, and this is the strength, and this is the evenness, and this is the yarn quality. Yarn should be even, always, everywhere. It should be even, and it should be stronger, depending upon again the say the end use for which it is used. And generally we are talking about the twin, say this one here, and so it will show you that it will be like this, like a twin that it makes. And then we talked about the quality. Say this is the quality, and this is the say appearance of that particular yarn that is being your that is coming out from this particular processing. It talks about that. And then so uh, accordingly the AI adjusts the machine settings instantly to prevent the defects. If there are any defects, if there are small knots and other things present on that, or if there are any burrs that are present, if there is any dust that is present, all these things will be previously it will be sensed by the particular artificial intelligence. That is when the tools that are being used, and then finally it adjusts all the settings by itself, and then brings out the quality that is being required. And then so here you find that fiber analysis is being done, that is length, and also the fineness, strength, and maturity levels. If it is cotton, that is maturity level is being taken up. So here you find that maturity is something related to the amount of say the cellulose that is present. In case of cotton fibers, sometimes if you remove it without ball opening or something like that, and it is not matured, you find only the cell wall that is present, and there won't be much of cellulose that is present in that. And so there are no layers of cellulose in that. And then what happens? These immature fibers will not go along with the say other the spinning parameters. They knot up and in particular places. And if even in more immature fibers are there, you find more knots, more slubs in the yarn, and which is a problem and with the quality, and thus we need sometimes even the maturity if it is the case of cotton. And impurities, I told you that impurities like burrs and leaf fragments and other dust and other things will be there, and these should be removed, and it will be taken care of by the AI. And the spinning parameters, you can see that the spindle speed and yarn tension, twist factor, and the draft and the temperature and the humidity, definitely they should be lower, otherwise there will be more of breakage in the mill. And so they will definitely, the temperature and the humidity will always be maintained in the spinning mills. So there is see, when by seeing it, A status is saying that it is optimal, and we are getting the predicted yarn quality is around 96%. So the quality trend excellent, and also the breakage is low. So they are looking, I mean, together showing that it is high quality and consistency, and there is a less wastage, and this is resource efficiency, the utilization, and then higher productivity. And then you can see that autonomous vehicle with robotic arms loading bobbins. And see here also, whenever it starts, in the actually the supervisor, or they need not actually look into this. And when they give the machine will come and pick up these things, because it knows where exactly the yarn count bobbins are there, the required ion count bobbins are there, and also the colors and all other things will be there, and it will be picking it up and then bringing up. There is a robo that is being utilized here. Then coming to the machine form, the fabric formation. And learning models, these monitors loom also knitting machine performance. In this, what happens is, uh, that there are looms and there are knitting machines. Looms are definitely, there are, very, very high speed looms are present today. Like you have, rapier looms and also that air jet and, you have also water jet machines and rapier machines are there. And so all these machines are very, very high speed. And so these things will be able to produce at a high rate. And so if anything happens in this, in a supervisor or whoever is taking care of that machine will not be able to see also. When the fabric is being made, whether the thread is broken over there or whether there is any half of the thread that has come, and whether the uh, say the reed, whether it is actually making the beating the fabric to required say space or not. All these things are problem here. And so AI machine learning models, these monitors the loom and also knitting machine is performance. And here, they detect the defects like broken ends and mispicks. I told you that it may be half of it and the mispick is there. And so the read speed will be, monitored here. And if the read, beats the particular thing, and then there will not be mispicks. And if mispicks are really required in that, and then the, say, parameters or such that all the arrangements are made like that. And then they optimize machine speed and tension. So if there is a breakage, I told you that it will definitely bring down the machine speed and also the tension that is there on the warp yarns. In case of the looms, weaving woven fabrics, you find the warp yarns being on tension, and it will be optimized over here, and then the tension will be automatically brought down by this, and then the tension will be reduced, and then you will be getting the smooth fabric. But if the tension is there, the fabric will be having a kind of wrinkling in the fabric, and that which you cannot, later make it all right. So it becomes a waste, or otherwise it goes as a seconds. And then it enables predictive maintenance to avoid downtime. I think I already talked about it. That means that it gives you a warning in the beginning itself that, that particular machine, the part of the machine is going, it requires maintenance. And so go for it. Otherwise, if the machine fails, then you will have to wait for the person who comes and does this thing. And also it happens to our homes. If something goes wrong only, then we'll go. We don't bother about, whether it requires maintenance or not. So in the mills also it happens, and that's why AI will be able to definitely help it. And then there is one system here that is a fabric defect detection. So this is a very, very important one because it really brings down the wastage, and thus, it will improve even the quality. And sometimes when the customer gets the fabric with many stains and also with a little bit of some flaws, like a difference in the texture, or if there is a stain in the present, or if this is a misprint, or there is a hole, all these things will have a problem. And so for them, the production lines, we cannot see in the high, this is a high speed production line, and so we cannot see our human eye cannot detect all these things because it goes very high speed, and we will not be able to actually see whether there is any stain, whether there is any difference in the texture, or whether there is any misprint, or whether there is any stain that is present. So this, definitely this AI, that is, say here, there are two tools, and there are AI 2I for the defect detection, and also AI 2C, 2CAM, sorry, 2 cam for simulation and prototyping. So these are the things that are there, and so the fabric defect detection, and because it is an automation in the industry, so it brings an automation so that this are automatically detected, and so it will not be sent. That particular material will not be sent for another say dyeing and printing, and so these things will be again processed separately, and then it will go get into the mainstream. So this is the use of this one. If you can detect all these things will be removed. Stains and other things can be removed. Misprints also maybe a problem, but texture inconsistencies and other things can be make they can be made right, and then they can be utilized, they can be mixed with the other say mainstream of say processing the material. So here there are high resolution cameras. They capture all the images continuously on the fabric. See, then the AI model and whatever is there, it analyzes the real time to detect and classify the defects. And we need to classify the defects also. There are minor defects and there are major defects. And there is a 4-point system. Whenever the fabric comes, even in this one, we will be looking for the defects in the material. Say 100 meters, they will be able to take it up, and then there should not be more than four defects or 5 defects, like that. And if it is said, then it will not be say it will be processed separately. That material cannot be taken. So that and all, that 4-point system, and I think I have an experience in the ISO 9001 14,000, where now we have gone to the mills, and there I was engaged by the Det Norske Veritas DNV from the Netherlands. We have given them the ISO certification when they are able to actually classify some of these systems. This is one of the things, one of the sections where the fabric need to be, detected for the defects that are present in the material. And here also, I told you that in the same way, people are not bothered about see whether they really the people who are there, whether they really given that much of education, they'll be really detecting this or not. So they are supposed to give the information to the supervisor and all. So for them, we have just told them that when you find the stain, please put this color or the colored bead into one of the cylinders over there, like that. And we ask them to do this one. And so here, this is not required now, because there is a artificial intelligence that is coming over there, and the machines are they are equipped with the automation, and these things will be able to detect these defects, and then they analyze and classify the defects by themselves. And then where these actually this fabric defect detectors are being used, and this uses image processing, and transforms and transforming quality control in many of the industries today. This automating the inspection process enhances efficiency, and I told you that it reduces the waste, and also it ensures super product quality. And so when these things are not there, even the customer will be very happy, and even the customer may not be giving that much the say price to us, but still, and in the same price, if you are able to produce good quality, and then they will be happy. And today, that it is a competitive world, and if you are able to give that good quality in the same price that we are looking for, in the price that a customer looks for, it will lead to continuous orders to the particular company. And so, and this is all, if they are equipped with the AI driven and with the automation, definitely it is going to help them, and also bring about efficient goods, and it improves the accuracy of that. And also we are saving the cost, and also we will be able to scale up at a higher percentage of the production. And because of that, they may be we may be getting so many people, I mean the customers for our side. And this is quality assurance, and is also possible over here. And so it is assures the quality. whatever the price may be, it assures the quality. And within that, we are, of course, working out. And so it assures the quality. And for the fashion and apparel industry also. And the brand consistency. For example, you have a lot of brands that are there in the apparels. And so in these brands, they will go for the smart textile mills because they are all automated and AI driven. And so there will not be any scope for getting defects. And so all this, maybe they are ready to provide, they're ready to pay also high. And because the material that they need to make it this particular brand, the fabric should be very consistent without any defects or any variation in the material that is being supplied. And even in the home textiles, the premium quality production will be there, and it is also brings about efficiency. You can find here the photograph being, looking at the, say, production details and also ensuring the quality of the material. And here, this is, we are enumerating all these things into this. It is predicting the future of weaving and knitting in a way. So we have a real-time monitoring that is capture every detail from from the fabric to till the fabric is being made, and from the yarn to the fabric being made, and it analyzes. So it detects the patterns that are there and predicts also issues. If there are any issues in this one, and the issues are brought to the notice of the managers of the company, and then accordingly they can take the decisions. So it can optimize the parameters and also the prevent defects, and then so it auto adjusts by itself and improve the performance. And so the smart actions they'll be able to do it. And just now we talked about the AI vision, which identifies, the broken ends, the mistakes and slubs instantaneously. And then the performance optimization, it adjusts the speed, the tension, and also the breakup in real time for best efficiency. Whatever we have talked, I think we have put up here, and the predictive maintenance, all these things come together and then make a good quality materials over here. So this machine efficiency, whether it is good or not, it will be able to they predict, and maybe it is a 92% efficiency, and the defects. Defect size and all, the rate and all should be coming down around 1%, less than 1%, so that the wastage will be less, and so the cost, it will become cost effective. And so weft insertions, so this is on track, no problem, and the warp tension is optimal, so there will not be any tension that is happening on the warp yarns. And the product downtime. So in 5 days, maybe in 5 days, that real time starts and ends by then, right? And so like that, they're all given like this, and then accordingly, all the parameters are being adjusted by the same artificial intelligence. There are their vision, a vision, and the machine learning, and all such things. That is Internet of Things, and all these things will be able to definitely bring out this. And here also in knitting, we have so many things here. And so here we don't have a Wapion and Wepion. Here, everything goes out in the form of loops. And so, and here also the machines, whether what is the machine efficiency, 94%, and the defect should be less than 1%, and stitch quality should be good and excellent, and the yarn breakage should be low, and then predictive and downtime time maybe 6 days over here. And so by taking all these things, and so by taking the computer in vision, and that it will be able to inspect stitches, and whether there is any hole that is happening. Holes are happening in say very easily in case of this one, because if one needle, if there is any problem in one needle, if it cannot take up the proper loop, there will be a lot of problem in this. And then you find that the whole row of these things will be missing. And so, and with that, if it is warp knitting, it's okay. If it is weft knitting, the whole thing will come out. So we have to be very careful with this. And so this will be able to inspect stitches and detect holes. And and there are any dropped stitches, and there are any uneven loops are also, these all these things will be detected by it, and then it will be able to also make it all right. That means it will not be it will be making a kind of changes in the parameters, and see that it will not be coming, or it will not be continuing in the netting part that is going to happen. And so it also fine tuned the speed, and that the feed, the loop length, and and the sinker movement, how it moves from one to another. That is the needles that come over on the top, and then taking from here the needles, and then they sink together, and then they will be taking the loops from one to another, like that. That sinker also, sinker movement should also be good. And like that, there should not be any breakage of this one. And so it adjusts the settings so that there will not be any tension, and there will not be any problem with the sinker movement and other things. So with this, with the AI, we'll be able to produce it at a higher scale, and then we're producing a better quality, and the downtime is less, and then there is a lower wastage, and also we are sustainable manufacturing. We are not adding heaps of this wastage into the garbage, and thus we are sustainable. We are going into the sustainable manufacturing, and so finally it leads to higher profitability to the company. So maybe there is a higher investment in the beginning, but definitely it is going to help it to bring down the costs, and thus they get the profits, and they're able to even go for the mm, with the investment and other things, they will be easily getting into the profits without taking much time. And then, so here, wet processing, coming to the wet processing, and means I told you that the fabric after the fabric is made, you cannot use it because it will be having, say, for example, in cotton, it will be having that wheat color, that wheat color, which is over there, and it is not, say, always, attracting the people. And so it has to be, and also say, the fall and all other the hand and all that, it will not be that good. And so it has to undergo definitely a transformation, and this happens with the finishing process. So dyeing and printing also a type of finishing that is being given to this. And I should say that dyeing and printing is one of the most impactful areas in the textiles, where AI will be controlling the quality of these materials. And here, what happens, I told you that in the beginning itself, that people who are working with the dyes and all, sometimes they are not the workers, they are not exactly, the say, scientifically educated people. And so they just like that, they will do that kind of thing, they will take this much on this much chemical and all. And even if you tell them that, they say that we have been doing it for so long, and why you want to tell like that, they are like that. And so these people will not be taking care of all these things. That's why there is exhaustion problem, and there is a pollution problem into the that effluent problems are there with this. And so here, it predicts dye recipes based on the fiber type and also shade requirement. And that shades are very, very important here, and should be less than 1%, or 1% up to, and depending upon the customer and these people, and the producer and the customer, and they have an understanding, and the shade which comes out to the market, to them, and they should be able to produce a similar one, and maybe say 1,000 meters or 2,000 or 5,000 meters, and it should be having a consistently the same shade. In that case, if they are going with the different color, different time, the dye and also the chemicals, if they unevenly take it, it will not be getting the proper shade here. And so AI predicts exact dyes, recipes. That the dye should be this much. Say, for example, if the material is 1 kg, or if 10 kgs material is being taken, and this must be, say, the shade can be really is around 2% shade, and this much dye should be taken, this much chemical should be taken, and this much water to be taken. That's material to liquor ratio. All these things will be predicted and given by the say the AI enabled machinery. And so there is a lab which gives this one. And so the samples can be prepared by taking this particular thing. And then if the shade comes out in a way that you require or the customer requires, and if it is exactly matching, maybe around 1% leverage is there. And if it is matching, that type, and then the whole system will be now loaded with that kind of the recipe, that dye recipe. It will be given to that, and then finally the fabric will come out, and the fabric that is that comes out will have the consistent color shade, and the matching shade will be there, and there will not be any the say I mean say for example like seconds and all will be given, because the you will not take it and then will say that I don't want this material. So if it comes to the back to these people, and then they have to just sell it off to in as a seconds, and they will not be getting any material money, and not even the processing. So even why we say that a defect should be taken in the beginning, because that material again will be dyed and printed, or it will be finished, and then you find the same kind of say defects, and these defects the customer will not take the material, and thus you're losing the fabric making, and also you're losing the money that is you have invested on the wet processing. And so the say defects have to be detected in the beginning itself, and so that there will not be much wastage in these materials, in the production of these materials. And also it minimizes the trial and error. So I told you that these people trial and error, they have learned it, and then they try to do it, but this minimizes trial and error, and thus the downtime, the time of the production will be lessened over here. And also it reduces water, chemical, and energy consumption. This is the that is say saying in the industry now, that is become popular now. All the machinery are produced with less water, and that is it earlier it was 1 is to 20, now it has become 1 is to 10, and the machines are there, it is even coming it 1 is to 20, 20 is to 10, sorry, 1 is to 2. That means that the fabric is one, and the double of that is the water. So it is happening today, and they're bringing up the machinery, which with a lot of automation, with a lot of AI induced materials, and so that the machinery, it is coming out with the by utilization of water, and sometimes there is no zero water also. Only it is sprayed with the color, and that type of machinery is also coming, and all these things are leading us towards a sustainable production. And so it reduces the water consumption, it reduces the chemical usage, and also because of this, energy will also be less. And and then there is a digital printing today. And digital printing, I think that how we print our own say pad, say this in the computer, how we print a paper. So in the same way, the fabric is also printed using the computer, this thing, and only you have to give, what kind of, say, printed design, and or it a photograph or anything, it will exactly come in the same way. And this optimization will be done by the computer, because computer has to identify what are the colors in each one. Because if there is for example, if there is a scenery and you have a lot of shades in that, one shade is different from the other shade, very difficult, unless an artist comes and then he makes his own, and that is also trial and error method. But here, this AI enabled digital system, it will be able to optimize. It will say that this color at this particular point, this is redder, and this is yellow color, and this is something, and this will be able to tell, what kind of colors, what type of dye, what type of things will be able to give that particular shade. This is so that's why digital printing optimization with pattern recognition is easier with the help of AI. And in the case of coming to the finishing process, it will say finishing means we have a chemical, and we have a machine, and which will give like a padding machine, and it will be having a trough with containing solution which will be contains a chemical, and it will be maintained at a temperature, at a one temperature, and also a pressure, and then the amount of chemical that is present. Okay, and so this AI can help us to control the finishing parameters. If this is temperature, it can control the pressure, it can control the chemical application also. So if these things are there, and it is easier to get out into the finishing process. In the machine, in the ordinary mill system, if it is not a smarter one, and the if it is a ordinary mills, what will happen is this, they will be putting up this chemical, and then what happens after some time, maybe after doing around 100 meters, then again they replenish the particular thing, and the finishing trough with the chemical, and with the fresh chemical, but they are not sure whether this is having the same thing. So the first 100 meters may be different, and this 100 meters, another 100 meters may be different, because they're replenishing and doing it. But if it is AI, when predicted, not AI controlled one, the quality can be controlled, and it will give you immediately that the only this much of original chemical you pour into this, so that you only replenish with this much amount, so that it will read the particular solution, and then it give you that yes, it is correct. What we have done earlier, this is also correct in the same way. So there is a consistent application of the finishing chemical on these materials, and so that the quality is ensured. And also sometimes the feel of the fabric is also, and the very much important, and the performance. So if it wrinkles, and the wrinkle resistance have to be there, and for example, the wrinkle resistance or the crease resistance finishes are given to the material, and this will not be should not be wrinkled, when you are washing it and all, you should not wring it the material and all. So the feel of the material may be little bit affected by giving the wrinkle resistance finish, because it's a resin finish, and resins are usually stiff materials. And so the softness, the feel of the material, if it is not good, it will suggest something, and some other, finishing problem, finishing, finishing a particular type of finish that it may ask for you, in order to improve the softness of the material. Thus, you can improve the performance of this one. Say, for example, if you have a problem with the this one, the stiffness of all it, and then you may go for the mercerization and other kind of things, which will improve the softness of the material. Or there are softeners that are they are available in the material. In the softening chemicals are there, eco-friendly softeners are there, and the material may pass through the softener, so that it becomes all right. Okay. And so something like that, it will take ensures the feel of the fabric, and also performance, which are very, very important at the customer level. And also, so it will monitor whether we are going through environmental, the eco-friendly processing, and so that we are ensuring that there are environmental conditions that stay without any difference in the mill. And so it also improves functional finishes like antimicrobial, water repellent, and you can stain repellent, stain removal finishes like that. And also durable press. All these things, functional finishes are there. And if it is being, uh, having an artificial intelligence, if it is artificial intelligence driven, then all these things will be giving a very good quality. And because nowadays we are getting antimicrobial, we are not very sure whether really it is antimicrobial, but it will test. If it is a AI enabled machine, it will be able to see whether the antimicrobials will be able to come up on that, and after how many washes it will be able to give you that this growth will be forming. And because the chemical that is present, which is giving the antimicrobial finish, antimicrobial property to the material, may vanish after so many washes and all. So, and it will be informed to the customer who is actually buying it. And so in wet processing, that is color matching. So in here, color matching is a very, very important. I think all of us know that colors plays a very important role in buying the material. And so I want to know whether I'm exceeding the time. Am I exceeding the time? Can I hear? Okay, this is sample input. We are taking the sample, and then that will show you by using that sample. We have an say color lab, and which will tell you about what is the lightness, what is the A means it is redder or greener, B is the blue or yellower, and how much it is there. Minus means it is yellower, and that is greener. Minus will indicate, and then it will provide the recipe for prediction, and then that is the trial will be taken up by the these people, and at the level of the say lab, and then finally you will be getting the sample, and if this look at the sample whether it is going to be say when matching with that or not. And so, and this here you find that this is the actual color lab, and which will in the computer they will be giving the recipe, and here there is a syringe that is attached to this, and all these dice are all over put up over here and with all the shades, and accordingly it will take up the from the particular shade, particular cylinder only where the color is there like this, and then they finally bring it, and then all the with all the chemicals are also in the liquid form, and it will be brought over here, and then they make the samples, and then finally they get the particular color. And so this is textile finishing. This is a smarter finishing with the AI for better textiles and better tomorrow. And you find that this is machine learning and computer vision and big data analytics and Internet of Things, sensors and digital twins. They all play a very important role in bringing up the softness and comfort that is required in the material, and then it makes it more beautiful, more durable by having the more strength, and so also shrinkage and abrasion resistance, and color brightens the shades, and better appearance and sheen of the fabric, and functional properties, that is the important performance properties are being given, like I told you that that is maybe stain resistance, water repellent, and wrinkle resistance and all, and then the fabric breathability, and when it is so that means that moisture management is required in some of the fabrics, and that is in layered fabrics, that is very very important, and so it will take up this one, and then sustainability, whether it is eco-friendly or not, it will be able to see, and then the customization of this, how it is able to customize the finishing process required by the customer. So, and so a powered finishing platform, and you can find that there are digital, see digital, this is one of them is the digital twin of this one, and so they show that it is this way we are getting the particular material. That's how and this will be compared with the product that comes out, and then they will be able to give this efficiently. And quality control and inspection, and computer vision, and this replaces manual inspection. Of course you know that there is no need, and it also detects fabric defects, and it classifies defects automatically. I think all of this we have already seen, and so with all these things we'll be able to control the quality at each and every point, and then we'll be able to get it. And the supply chain and process optimization also, and it integrates the data and the textile value chain, and it also forecasts demand and production planning. It helps in that, and it optimizes inventory and reduces overproduction. This is very, very important that you have to see how much we have, and then we need not buy and also produce overproduction if you go, but and you cannot be able to sell this, and so there will be a problem. And so it enhances the traceability, and so this will be able to you'll be able to do it. And then in textile processing, I think all these things I have enumerated over here, and all these they say yarn and fabric, fiber and yarn processing, and dyeing and printing, quality control and inspection, and weaving and knitting, and finishing process and supply chain process optimization. And so we are able to produce sustainability and resource efficiency. And technologies here are used on machine learning, computer vision, the Internet of Things, that is sensors and digital twins, and then cloud computing. And so sustainable, when we talk about sustainable processing, so there are also environmentally responsible methods and materials in textile production, that is reduced eco-friendly raw materials and reduced wastage and emissions, and then recycling and reusing the water, and then ETPs, I told you that way they are there, and they treat the material, and then it can be used again, the particular water, and then we are protecting the environment, and then going for the this is a circular economy that we are able to take up. And then there is a sustainability and resource efficiency. Then it contributes significantly to eco-friendly textile processing. So eco-friendly sustainability is that, we reduce water, optimize chemical dosing, track carbon footprints, and support circular economy. And then there are definitely challenges that are there. The high initial investment is required, need for skilled force, and that is very, very important. And data integration. So with that integration is very difficult with the traditional mills. I told you that they will not be able to provide the correct data, and so there will be a problem. And then resistance to technology adoption by everybody. So AI tools used in technology processing is that we have a machine learning. I told you that it may predict fabric quality, defect, and process outcome, and then optimize process parameters for better performance and efficiency, and reduce chemical and water and energy usage, and then continuous learning from data for smarter decisions. Like that, computer vision is real-time fabric inspection, and then it detects defects again, like stains and other things, and you can find some of these things. And the internet of things, it will be collecting real-time data from machines and environment. It monitors temperature and pH and all the say parameters of the machine, and parameters of the particular I mean say the liquid that is present and the finishing process. And digital twins, I told you that it will be giving a kind of a digital twin that with this quality you'll be able to produce this fine. And so and by taking this into consideration, they'll be able to actually match it with this and say whether the quality is there or not. So all these things will bring higher quality and lower and at a lower cost, and there's a less wastage and more efficiency and more sustainability. And then coming to the this natural dyes. In this, natural dye arena, they say here definitely we require the AI, and I'm thinking of by doing this AI here, this lecture, I thought, I should be able to incorporate this AI into the natural dye, because there is a definitely a requirement is there, and most of our artisans are suffering. And what are the things that they have to take and how to do this processing, because they have taken the processing from their seniors and all. There are a lot of things that are being missing, and they are unable to do it scientifically. And so natural resources include the plants and minerals and insects and these materials, and we don't know where they are and where they are available. And AI system definitely will be able to help us, and we can identify where exactly you will be getting the particular source at a high pigment level, and thus we'll be able to purchase this at a lower price. And it also image recognition to identify plant species and quality. I think all of you know that this mobiles are having this particular thing, plant recognition, and you will be able to recognize the plant. And also, if this is comes out, and it will be able to give us whether this will be used for the getting the pigment or not. So it also pigment concentration also there based on northern season and maturity. And this is something which is having a problem, because whenever we maybe we collect the raw materials, if we collect it in summer, it will have one kind of one percentage of pigment. And if you collect it in another season, and the maturity of this all will be varying. And so AI, if it comes, it will be able to take up the data, and by doing, and then it will be able to give us that this season, if it is being collected, then it will have only this much of pigment. And so it also predicts dye outcomes, how it is going to come up, and the color and other things, shade and other things. And it can optimize the dyeing parameters like, we have a, say, again, we here the temperature, the color, how much resource we have to take. That is dye source, how much we have to take, and in what way you have to take, and whether you need to soak it for some time, or how you have to do it, whether it is in water, or if you do it in say solvent, it comes out correct. All these parameters, dyeing by it optimizes and give us, so that we can blindly follow it without any problem. So it fiber, dye and mordant, that for each fiber it is different, and it cannot be same. And for each dye it is different. For each mordant it is different. So to get a particular shade, what are the things that you require? What type of mordant to be used? What type of dye should be used? And what of a kind of fiber that you are using? All these things will be processed, and AI model will be coming out, and this analyzes all these things, and then we'll be getting the predicted color quality. And so the extraction of the dye, it will be useful. It optimizes the temperature, time, and pH, and predict maximum how to get the yield, more yield, and it also reduces the energy consumption and over processing. Mordanting, what are type of mordanting to be used, and what is the optimal mordant type and concentration. And with this mordant, what are the things that you will be getting, and so it also minimizes the use of this one. Dyeing process, there's a real-time monitoring of the dye bath, and also it pH and temperature and color strength, all these things will be done. And here also replenishing the dye bath will be happening, and in that case, how much color which was there already will be increased by putting of the new color into that, and all will be monitored by the AI, artificial intelligence. And it also predicts the final shade before completion. You need not wait till it is the particular one dries up, and then you need not match it in the beginning itself. It gives the thing. So it adjusts process dynamically to avoid shade variation, and then the dyeing and printing, the final color develops during dyeing and oxidation, and then and so the final how the color is developed, drying and oxidations will be able to predict and show you, and it can also controls the dyeing conditions and ensures uniform shades and also the fastness of the. And why we need only in natural dyeing? Because there is a lot of variations in this material, and a lot of variation due to soil and climate and inconsistent pigment concentration. And I should tell you, in most of the say the actually source, you find that only 3 to 5% of pigment is present, and the rest of the thing is only a waste. And so what to do with the waste, and all these things will be given by this. And and if it is having more of this, and how to improve the pigment content in it also will be able to given by this AI. And so we'll be able to get predictive dye recipes with it, and we build a databases of traditional dye outcomes and also standardized shades on commercial scale. And so I think all these things, again, I think there is a less time here now. I think I'm not talking much about it. The raw material selection, how and AI can help us. It identifies the correct, say, sources, dye sources, and then we'll be able to take it and then do it. And then extraction of the dye, which extraction method can give you a correct dye, and also which one will be able to extract the full this one present in the material, in the source. How much it can be extracting, high percentage of the pigment should be able to be extracted from it. And mordanting and fixation, I think we will talked about all these things. This is only an extension of this particular enumeration of all what all we have taken. And so here, what can we do? For people who are starting with the this one, and so we have to know what are the inputs that we need to give a system where we can give the fiber type, the plant source, and the mordant. Then the output that is being given by this one is expected shade, the fastness properties, and optimal dyeing conditions. Fastness properties are important for especially artisans. They will not have any machines, any testers to test finally. What is the fastness property. And whenever we ask these artisans what is the fastness, and they'll say that it will be fast, ma'am, it will be fast. That's all. But they don't know the fastness to be tested. And if you want to export it, it should be tested. Fastness to washing, fastness to sunlight, fastness to crocking or the rubbing, and fastness to perspiration, and fastness to ironing under higher temperatures. All these things are required, and so this will be able to give, without without buying the testers, it will be able to give it by just seeing the material, whether it has really gone into the fabric or not. It will be able to give it. And so also it will be able to give optimal dyeing conditions. This brings so we are bringing the traditional wisdom and also the modern science together, and then we'll be able to give it to the artisans so that we'll be able to do it. And there are a lot of abundant research opportunities for the students over here, and by digitizing the traditional dye knowledge systems, and putting up with the original scientific data, and then we will be able to digitize and give it the everywhere. There are so many pockets of these things wherever it is there, wherever there is a handloom, and they have a system and which can be digitized by taking the original scientific information with their traditional knowledge, and so that they will not feel out of way. And so we should be, the AI should be speaking not lightly over there. And so we should not be saying that only, hey, yes, it is the one which is doing and all. So you have to be less authentic over there. And so we have to combine these two. And there are so many opportunities for the students to work in this particular field. And then so developing AI-based shade prediction models. So this is also one thing, and there are several, synthetic dyes as well as natural dyes, natural sources, and each one can be taken and it can be read through. And so there are a lot of opportunities again. They're developing the AI-based shade prediction models also, and then creating eco-friendly dyeing protocols with minimal water and chemicals. So by doing these two, we will be able to also create eco-friendly dyeing protocols, so that that artisan need not bother about what to take and how to take, how to go do for this particular shade and all. And so then thus we will be supporting rural artisans also with mobile based AI advisory tools. So I think agriculture advisory tools are coming now with the mobile, and now we can do with the give the artisans this kind of mobile based advisory to the artisans, so that they will be able to do it. And so I think I have some experience in this. I would like to tell you that we have done a value chain in natural dyes, which was a 5 crore project NAAP. And so we brought in around 10 to 15,000 shades of natural dyes, and with a limited number of say the sources. And so in that we brought in these colors, this nat color text, that is it is a AI driven natural dye shade. And that time I didn't know that it is AI driven, but this is out of my own brain child, I should say, that it is there are so many shades. Then I thought, why not we combine it with the these things, the say from where it has come, for a particular shade is there, from where it has come, so that the artisan or the customer will be able to tell them that you take only this source and this mordant and all those things. So in this, we have given all the shades, and if you say select the shade, and it will be able to give you the source, and the source, from the source, how much mordant we are also given, what kind of what type of mordant that is being used. And then the mordant, how much is the water, and how much is the mordant, how much is the percentage of the mordant that we have taken, like that. We have given all this thing, so that a person who is starting this one, I told them that it is a kit, like, and for the students and also artisans, so that they will be able to get into this and then do it. And then also we have given small this thing, that if a person, if a student, or if a artisan, if he has some kind of, you say, a 100 grams yarn, or 100 grams fabric is there, how much color is required for the getting the particular shade, how much color is required, how much color, how much mordant to be taken, and how much water to be taken, and what are the parameters, that dyeing parameters, dyeing temperature, pH, all that, all these things have been given to them in this particular thing. And so it is something, like now, so from the source they are showing, now it is what we have done a reversing system, but this is also AI, and I am happy to share with all of you. And also one more thing I would like to share with you is that characterization of woven apparel fabric quality, and this is being done by one of my student, Dr. Anita, from the Angro, and also she was a doctorate, and she retired from the university, Angro, and but she was a professor, and she has done it this one. And in this, what we have done, we have used neural networks, and in this neural networks, what we have done is that we have taken 75 fabrics. This is there on the, it's one of the projects that we have taken up actually. And so in that, what we wanted is that the fabrics are there, and for the mills and apparel, especially apparel mills, and it's very difficult for them to say how much strength is there in the material, how much wrinkle resistance is there, all that, all the parameters, physical and other the thermal properties and all, to predict it is very difficult. So what we have done is that in order to predict those things, some of the geographical geometrical properties are important. And so we have actually tested 75 fabrics, and all this data has gone into the neural networks. We have taken that data on geometrical, physical, and low stress properties have been attained, and also by following the standard procedures. And then we have taken this data and we have fed the neural network with this particular inputs. And there we have taken a three-layer neural network, and then and we have developed a neuron in each point. And then we have predicted the output out of it, and which has showed a correlation of 0.93% with the original data. That means with the 25 fabrics we have predicted, but we have already tested that one, but we wanted to show how it comes. What are the data that we get from here, from the predicted data from this particular neural network things, whether it will be matching with that or not. There is 93%, 0.93 correlation is there. That means that is an excellent thing that we could develop. And then it is more useful for both textile and apparel industry. And then we have the quality of the fabric, they can be able to predict it, and then by taking only the geometrical properties of that one, which can be easily done by them by say thickness, maybe the say the GSM, grams per meter of the material. That if that is known, it will be able to give that also the yarn quality, little bit of the thickness of the yarn and other things, fabric thickness and yarn count and other things. So fabric count, yarn count and all, they can be easily taken up and then I would like to say, so it is rapidly transforming, textile processing. It is bringing a very good greater precision and efficiency and sustainability, in the fiber selection, spinning, weaving, dyeing, and also finishing. So through real-time monitoring and with the predictive analytics and also process automation, AI helps reduce defects and optimize resource use and improve product quality while minimizing the water, energy, and chemical consumption. And here, we are not leaving out the, say, traditional knowledge. And so we are taking the traditional knowledge systems and we are trying to preserve the cultural and ecological value of either natural dyes or any other system, say, even handlooms. We like to take it between, and then uh, try to bring them together and then predict things and then bring out equality in the final fabrics. Although its role in natural dyes is emerging, in AI is emerging, the broader impact of the AI lies in creating smarter, more responsible manufacturing systems. Overall, we can say that the integration of AI into textile processing represents a significant step towards a more efficient, sustainable, and technology advanced textile industry. So, the friends from the industry, please be aware of this AI that is being coming, and also the students. And you have a lot of opportunities for taking up this into your, taking our thesis, or if you're taking into small projects, and then try to do it, try to involve the, say, the handlooms, the natural dyes, and most of the other things, how you will be able to complete. If you have a pocket of natural, this handlooms in your place, and try to bring out some kind of artificial intelligence to them, try to help them. And this is how you will be able to take up the projects and then do it. So thank you so much. And finally, I would like to thank all